Next up, Michele Polastri and Marco De Biasio will present what's new for Scia.
Welcome to the release event for version 26. We are here today with Marco, product manager in ALLPLAN, and we will talk about engineering. So this world of engineering is evolving every day, and structure are taller, smaller, and the main challenge is also with the sustainability that we need to reach. We need to gain in material, we need to optimize our structure more and more. Optimization process is a difficult one and brings also to have lighter structure with probably smaller section or thinner, surfaces, slabs, and element that really can hold our structure. This brings to different challenges that then engineers are facing on, because when you start to, reduce the material, even if you have stronger and better material to use, then there are other difficulties. How did we tackle them, and what is your impression over this topic?
Yes, in Scia Engineer version 26, we face some of this problem, and we try to bring new solution. One of the first problem that we want to challenge is the one of human-induced vibration in buildings. As you mentioned, the slabs are becoming more and more lightweight, made of composite, sometimes with wood, sometimes voided slab. And lighter the slab, easier the possibility to incur in vibration induced by human activity, people that are in offices or people that walk into the corridor of an hotel, which is the problem in this case. The problem is that situation in which an discomfort for the people can create due to the auto-induced vibration. And also the serviceability limits of the building itself are surpassed. How to deal with this? In Scia Engineer version 26, we introduced the new footfall analysis. This allows already in phase of design to predict the behavior, the vibration that it will occur into the building due to human activity. It's an approach that is based on design code, based on code SCI, AISC, and CCIP. So we cover the three main codes dealing with vibration human-induced. It will enable the engineer to extract directly meaningful values like response factor and vibration value dose. And why it is important? It's important because too often in practice these problems are discovered once the structure, the building is already operational. But with the possibility to do this already in the design phase, the problem can be predicted. Then this will enable the possibility to avoid expensive and costly retrofitting action. Again, it's something that is very important for a structure made of composite slabs, lightweight slabs in general, but also for buildings that are of particular use, like hospitals, like scientific laboratories, and as well as for footbridges. So I think it's a very nice novelty in Scia Engineer version 26, this one.
Definitely, that looks as an impressive solution, let's say, for this type of problem. And well, we saw in this last slide that is passing a typical structure, let's say, that our engineer deal with, and multi-story building, lightweight slab. No, the problem is the punching with walls, with columns. What are the solutions that we offer in that?
Yeah, the problem of punching of slabs, it's a problem that can be very quickly, let's say, neglected in phase of design. We had already in Scia Engineer until now the possibility to perform design and check of punching with respect to column of circular and square shape. In Scia Engineer version 26, we extend these capabilities, and now we are able to design and check for punching with respect to walls corners, walls ends, and also with respect to columns of any cross-section shape. So we are able to cover all the spectrum of punching possibilities for reinforced concrete buildings.
Wow, that's for sure a fantastic improvement that we propose to our user. And going back a bit to the footfall analysis, we mentioned, problem with lightweight structure. We also saw, the Millennium Bridge, I think, is one of the most iconic case. But going there then on the civil structure, what are the news that we can share with our user?
Yeah, the domain of civil structure, it's a domain that we care particularly about. In version 26, we introduced two main novelties in this sense. The first one is moving loads. Which is the problem with moving loads? Every time you have some loads that can assume different position in the space, it's very easy to end up with a number of load combination that is huge. This implies the fact that the computational time becomes huge, as well as the time for post-processing. So how to solve this problem? We solve this problem using the mathematical theory of influence lines and influence surface. What is that? Is the possibility to compute a priori via mathematical functions, which is the position of the loads that generate the worst case scenario with respect to the response that we are looking for, like moment, displacement, reaction, and so on. What this implies? This implies the possibility for the user to identify a priori among the millions of possible load combinations, which are the few load combinations that are the designing one, so the worst case scenario, and then to perform the finite element analysis and the post-processing only for this limited amount of load combinations. This will generate a huge saving in timing for computation and for post-processing. And in Scia Engineer version 26, we introduced this two feature both for 1D elements and for 2D elements, so surfaces. The implementation is very complete and sophisticated. There is the possibility to use all the load library coming from design codes. There is the possibility to synchronize or less or not the load across different tracks. There is also the possibility to use a diffusion cone for the load on the surface, so to take into account about the effective depths of the slabs, and so the user can use this feature for bridges, for, let's say, for people that do industrial buildings, for cranes that move along the industrial buildings, for taking into account the effect of the lift, the elevators into high-story buildings, and others. So it's a very nice implementation for a user.
Yeah, congratulations, I think. And also, it looks like a really strong approach to save time,
yes,
especially in the post-processing phase, where I think one of the, let's say, challenges are dealing with this type of structure.
Yeah.
And yes, staying on the civil structure, we are talking about moving loads. We talk about retrofitting. So loads are changing, challenges are there, and also new approach. Luckily, we have an improvement in the software, but this means that also we need to go back on existing structure and deal with them. What are our let's say solutions and key points on this topic?
Yeah, you said well. If you look around, the most of the structures that are built are old, are not new ones. The most of the buildings or civil structures that are out there and are made of concrete are more than 50 years old. And sometimes they are approaching that 100-year-old, so they are at the end of their design lifespan. So the challenge here is what we do with the structure. We demolish them and we build new, and so this costs really a lot, or we try to see if we can extend the lifespan of the structure. So in this last case, what we look for is solution for retrofitting. Now, one of the main solutions for retrofitting of reinforced concrete structure is the use of post-tensioned external tendons. Why they are used is because they are cheap, they are easy to put in place, they are not invasive. Till yesterday, we were not able to simulate their behavior with Scia Engineer, but starting version 26, we are able to model analyze and design with respect to post-tensioned external tendons. And moreover, this implementation is also fully compatible with construction stages. So the people that design and analyze more challenging structure can really take advantage of the combination of the two, post-tensioned external tension and construction stages. So in order to figure out all the pre-stressing, let's say, workflow.
Wow. I think there is also a small surprise as you mentioned construction stages. There is
something that it's a small improvement, but was asked by many people is the possibility to, let's say, reuse variable load cases on multiple phases. Till yesterday, if one user has several phases and defined variable load cases, if he was using it in one phases, he could not find them anymore in other phases, so he had to redefine other load variable cases. Now instead, if the variable cases, let's say, are used in more phases, the user can freely do it as it's a standard load combination.
Okay, great. Going back a bit to moving loads, we talk about moving load on 2D elements, but mobile load on 1D element is also important. This can definitely be a feature used in frame structure.
Yeah.
So we'll talk about crane in this case, for example. But going to the frame structure, this then brings other challenges, other obstacles to our engineers because we need to simulate the right behavior.
Yeah.
And there is an important aspect that sometimes is a bit overlooked. That is the aspect of torsion. What can we say about that, and what our solution to these challenges?
Yeah, the problem of torsion is very important, as you mentioned, because even if the user sometimes can have a tendency of underestimate this phenomena always exists, because as soon as there is an eccentricity in a load that is not applied exactly in the axis of the element as it was designed for, or an eccentricity in the support, there is a torsion. So torsion is practically present every time. And which is the problem of torsion for 1D element? The problem comes from the base, from the beam theory that it's used in the formulation of standard finite element. Why this is? Because this theory totally neglects the phenomena of warping that is present in reality. What is warping is the fact that the cross-section deform along the axial axis of the structure. And deforming in this direction imply the creation of a new component of stresses. Now, how to deal with this? We can deal with this, and we do it in Scia Engineer version 26, through the adoption of a new finite element formulation that incorporated an additional degree of freedom that takes into account the deformation of warping. The result is the possibility so to do a more accurate simulation of the reality, and so having safe results and more accurate prediction, and sometimes it translates in an economical design. But also there is another practical advantage, that is if a user uses a finite element beam with 7 degrees of freedom, he is entitled to skip the design checks for lateral torsional buckling, because as a user probably know, the Eurocode clearly states that if the warping it's explicitly taken into account by the numerical simulation, there is no need to perform a check for lateral torsional buckling, and this can be sometimes very complex to do with the formula of the code. So this can be something very beneficial in terms of time saving for the user.
I think you really went through a key point, not only for today, but also the progress, let's say, of the code. We are talking about Eurocode, but there's a new Eurocode approaching, that's the second generation Eurocode. And there, engineers will be faced with new challenges, with new calculation. And I think that the 7 degrees of freedom will offer an important solution to both avoid manual calculation in which the risk of error is a lot higher, and also to, let's say, have a more deep analysis and more advanced analysis on the structure. And I think we are already looking at the second generation Eurocode, right?
Yes, indeed. You said well, the new generation of Eurocode, the second one, is approaching, the release date is approaching, and at ALLPLAN we are already looking at them since several years. There is something that is already ready into the software, and user can use directly in Scia version 26. That is the second generation Eurocode for steel standard and for cold format steel. And in what concerns the other second generation Eurocode chapters, the work is ongoing and it will be ready. So we will release it progressively every time that we will finish some part of it. But speaking about code, there is also some new, let's say, some novelties that is in C Engineer version 26. That is the introduction in the a 3D wind load generator of the American code ASCE 722. So the latest iteration of American code for wind loads. We introduced it in the wind load generators, and at the same time we kept the old iteration of the ASCE 7 code, so that the users that are in US or design a structure for US, they can pick which iteration of the code they want based on in which state they are designing their structure, because as our user probably know, in each state of US has different, let's say, current version of the code that it's used. It's not always the latest one that is used in every state.
That's a really good solution, I would say, to then for all challenges in the US code. But I think for the wind or load generator, there are also some news for the Eurocode, right?
Indeed, indeed. There are two. The wind load generator is always an aspect of the software that is really requested, and improvements are asked all the time. And we did two new things in C Engineer version 26. The first one concerns Germany. We introduced, beside the wind zone 1, 2, 3, 4 that we were already covering before, we introduced the mixed zone, so the inland and the coastal zone, so in order to take into account for the full coverage of the German territory. The other improvement is more general, concern the 3D wind load generator for canopy roofs, and in particular for the use of the load generator with the force coefficient approach. Till yesterday, we were considering a limited number of possible wind direction cases. Starting C Engineer version 26, we cover all the possible cases specified by Eurocode for the wind load with CF approach, so that the user can stay sure that his design will be always the most safe and accurate that is possible.
Wonderful. I think we did the tour, let's say, of this new release. So just a few words, and now we can start to work with mobile loads. We can start to analyze civil structure, frame structure, going into depth and start using also the second generation Eurocode. We can use it Scia for retrofitting of civil structure and all the structure that we want to renew. We have solution for the punching that was an impressive one as well, covering all the spectrum of punching shear. And footfall, I think it was one of the most impressive solution that we give also to our user. So I think it's time to start having a look at this version 26, and we wish you a great day.